So for my term project, I created what I'm calling the Better.End.Effector. It is essentially a kind of program that's going to help visualize and help control end effectors, which are the tools that go on the end of a multi-axis robot. And the way that, or the inspiration comes from actually working in the DFAB lab in the architecture department, where we've actually had to work with some tools where it's not very intuitive. It's a lot of kind of MacGyvering to make it work, and I wanted to create a much easier, intuitive way of doing this, which in the end will help us make better projects because we won't have to worry about messing with this part of it. We'll be able to actually work on the design, and actually we'll also be able to come up with better ideas because we'll have a more robust way of controlling these end effectors. So just as a real quick reference, the main idea of using the servos comes from a project that one of our professors did, where, if I can find it, so here's just a couple pictures to kind of demonstrate. This was a project that our professor did while he was at Michigan. Basically, it put the plaster on, and then they have a tool. They sweep across the surface. This one has a servo motor, and it actually slides this piece back and forth. And then they run it along, and it actually kind of changes this profile as it goes. So that is essentially the very basics of my project. Interface that I found, it's called the Ice Explorer. I'm not really sure exactly what it does, but it's basically set up the way that I wanted mine to be set up, where you have tab windows that you can move around. You have your main graphics view in the middle that you can rotate and orbit and select different tools and look around different ways. And then at the bottom they actually even have a simulation kind of little toolbar where you can have different keyframes. It's basically the same kind of setup that I'm trying to create in mind. And part of the reason for doing this is a pretty familiar environment for a lot of designers, so the people that I'm designing this program for will be comfortable using this. So the Better.End.Effector is basically made up of two main parts in Python, and then there's a piece that is actually on the Arduino, but for right now I'm going to talk about the Python components. I essentially have the editor file and then the main file, and basically the main file just initializes everything and actually creates the application, and then the editor is where I have pretty much everything created, where I do a lot of the drawing and kind of setting up the commands for moving the servos and all that good stuff. But basically the way it worked, I have a couple other files or modules that are set up that basically do the translating between Python and the Arduino, and they are what actually talk to the Arduino and actually make the move commands happen. And everything else is done in here. So basically all you need to do is you go into the main file and run it, and it opens it's supposed to open up just this window first, but I was having some trouble connecting some of the signals and getting them to work right. So for right now, it just opens everything all at once. But basically, the idea is that kind of like a lot of design software, you open it first, and you get a little pop-up window that tells you about it, and then usually you can select your files. But in my case, what I wanted it to do was I wanted you to be able to select between different modes that I'm going to have available in my program. So basically what I have listed out here is single servo, multi-servo, and both of those would kind of change how many dials there will be, so you can see the dials back there. But those are all manual modes, and then there's a live control mode and a simulation mode. And the idea is that you select that and hit OK, and then that will actually change what windows are kind of on the forefront, and also change what dials are active, and also change what the dials actually do. So for right now, the default is set to manual mode, And I actually, just for this demonstration, I made it so that the top two servos are manual mode, the bottom two servos, or bottom two dials, are in live mode. But yeah, I'll show you what those do first. So basically, in the manual mode, you actually click and you can rotate the servo to change the rotation, or you can actually manually edit it in here, and then once you have it at the degree that you want, you hit send to servo, and I don't know if you can actually hear that or not, but the servo rotated. The idea for this is that you could have this is kind of custom controlling the servo, because previously on this project you'd have to go into the code, manually enter in the angle that you want, and it just wasn't a very intuitive process. So now you can just simply rotate a dial. And then what's more exciting are the live rotate dials. So basically you just click it and start rotating, and the servo moves. And I'll have a video, or I'll have a clip of it actually moving in a second. Oh great, and I crashed it. But that's the idea for the actual servo control. And then the main window, the idea was to have a 3D environment, but I wasn't able to get that working, so all I have right now is just a simple 2D environment. And the idea is that you have these two curves in here, and basically what the whole thing is supposed to demonstrate is what this top profile will look like, where the two curves intersect. So that if you were to sweep this across some plaster, what the form would be. So the first step was figuring out what the intersection of those two curves are. And as you can see, it's kind of failing a little bit in here and in here. I have to actually redo some of the intersection algorithm to make that work right. But what you can do is, when you're in the curve editor, you can actually move and modify the curves. Right now I have it just set up to keys, so the numbers 1 through 9 move each one of the points, so 1 and 2 move that point, 3 and 4 move this point, 5 and 6, and so on. Or you can move the entire curve together using the arrow keys. And the idea for this was that as you're rotating a servo, it would also be sliding this back and forth, so it kind of gives you an idea of what the simulation would look like, what the profile would, how it would change. And yeah, again, you can see some weird stuff going on in there. That's just a problem of how I set that up. And then the curve simulator, which wasn't able to get working, would essentially be the same thing, except it would be the curves displayed over time. So as you drag the slider or hit play, it'll actually show you that all moving, so you can kind of see what over time those curves are going to look like. What else? And I also have this set up. Again, I was able to get the tabs in there, so I don't know why you'd ever want to put it up there, but you can move the toolbars around to where you want. You can even pop them out and put them on a different screen. Also set up right now, this is just a blank toolbar, but there could be a couple custom tools up there for actually editing the curves when you're in the curve editor. And then another way of editing it that I think will be a little bit more intuitive, rather than just keys, is having some sliders that are actually tied to these points on the curves. So basically that slider would move point 1, that one would move point 2, and so on. And then the ultimate goal would be so you can just literally click in here and drag. That'd be the most intuitive. And then one other main feature of the software is that basically, again, as you kind of change what mode you want to work in, things update. So right now, if I go to the curve simulator, if I switch back and forth between my two main windows, it automatically changes and updates what settings I have available. So when I'm in the curve simulator, I can pick what servo I want to simulate, how many of them, I can set the mode, and do all that good stuff. And I also have a test servo connection, which essentially you just hit the button and it runs a pre-programmed servo movement just so you can see and make sure that your servo is actually connected. But yeah, so that's basically it. And obviously there's still quite a bit that can be done on it, and it kind of proved to be a lot more difficult getting this interface working and also getting the curves working. But there's definitely a lot of potential to kind of develop this further and make it even more robust. So real quickly, I just wanted to show you what a couple of the kind of Arduino side pieces of code look like. First off, actually within the Arduino, we just have this simple code. Basically, it sets up your servos and sets up some other, kind of attaches it to certain pins on the Arduino. A lot of kind of electrical, I don't know what you call that, electrical engineering stuff. But that's not what I was really interested in, so that's why I was glad that I found this already set up controller. But the important thing is that you can add as many servos as you want in here, and then basically it just takes in a serial, or over the serial connection, it takes in a string and breaks it apart. That's what this loop does here, into basically the move commands. And so what you send from Python is actually really, really simple. So there's this servo module that I have, basically connects to a certain port and then just tells it to move. That's really all it needs. So literally it just takes a servo and an angle, and then it sends that. And all the magic happens right in here, where it basically creates a string out of the move command. So that's just a simple move command that it understands. But then to actually make it something that I can use, I created this little manual move, and for some reason, which I'm not really sure why, I could only get it to work when it was in a while loop. If I just actually wrote move dot servo and then told it to move, it wouldn't do anything. It has to be, for some reason, in here. Not really sure why. Some weird stuff going on. But then also makes it very simple to create up some custom movements. So in here, just a servo random. So it cycles through the 4 different servos that I've connected and tells them to go to a random interval angle. And at the very end, they kind of sync up, and then it's done. And one thing that I found that was kind of strange was most of the code that I've been using, you can only control one servo at a time. I know it's possible to control multiple simultaneously, but the way everything was working, it's one right after the other. But as long as you have a small enough time delay, it almost seems like it's all simultaneous. And then servo sweep, which is actually one that will be really useful for the plaster work. Basically just starts at 175 and goes in increments of 1, and right now I have it set to 60, but it can go to all the way to 0. And that's basically what the servos would be doing as the robot is moving the trowel across the plaster, slowly sweeping through all its motions. And down here you can actually see, just for kind of my sanity, I had it tell me what servo it's moving, what degree it's moving it to, and then when it actually got to that position, just kind of as a little reference. But so basically, that's pretty much all that's happening on the Arduino side. And in a sec, I'll just show you a few examples of it moving, just so you can see how that actually works. Okay, so here's a real quick demonstration of the controllers. Now, here's the Arduino micro, and I have the computer speed right now, and it's pretty simple. Got simple, but I got servos. This is servo, and this pin is servo 4. We'll demonstrate live of the 4 line of this. Says basically rotate, and it's doing servo and roll. And then the other one can do that. And another thing is you can slowly just go up, nice, and then you come in here when you do obviously small. So I want 8. So now the move and have it connect. Then I come in, rotate, go to 150 servo. Maybe go back to the command time you click. And this, the whole if the whole program properly, you can hear to set it to it, and then dials with mode, or live as dials that work sweep mode, or not sweep mode. And I have sweep that sweep and hit a button sweep describe amount of rotation. And then the other thing controls now is sort of, this is actually all. It's the further RAM and then the sweep. Test it, every connected working. So you call the serving RAM, single sync. Oh yeah, you can do movement because moves. They're increment. Each one's degree. And that's sweep move. Yeah, basically command roll that you want to rotate. That I have all row connection. That this is because to this or that would be, but that just really hated just talking to it. Anyways, the better as I the bump like a lot of the use enter a lot of names. Upper, no,